Okay, super easy lesson today. Also, if you guys can find a graphing calculator for me, that would be great as well. Just as a reminder, your quiz or your test next week will be our first test that there'll be a calculator and a non-calc section. So if you guys can just make sure you go through the steps with us today of practicing finding an integral on your calculator. All those things are really important for the calculator section of your test. So the quiz itself that I gave you guys, there was no calculators allowed, but this upcoming test, there'll be 14 or 13 multiple choice that are non-calc, and then the rest will be 1 or 2 will be calculator, and the full free response will be calculator. So on the top, you guys see that prior to calculus, you guys were asked to, let's say, find the length of the segment that you see I'm highlighting right here, to find the length of that. And we did that a couple of ways, including, can you guys, actually, I think I'm fine. Okay, so to find the length of that, can you guys type into the chat what formulas come to mind? If I asked you guys to find the length of L, what would you guys say you would use to find that? Okay, good. And so from Pythagorean theorem is where what most of you guys typed out. We developed the distance formula from that. So that's where we're going to go here. And the nice thing about what we're learning, just like with area and volume, is it advances our capabilities of finding the length of things, in this case, length of things that aren't necessarily just a straight line segment. So you guys can see here this curve that we have over here. Now we'll be able to find the length of that. In theory, if you guys were to stretch that out, if that was a physical representation, we'd stretch it out and just measure from endpoint to endpoint. However, what we're going to do instead is keep it like this, but understand that as we find the length of this entire segment, what we can do is find the length of each one of these segments that we're connecting along the way to get from each point to the next. And then what we do from there is sum up the lengths of all of that. If we reduce the change of x, and the change of x is the distance between point 1 and point 2, or in this case, point 0, p sub 0 to p sub 1. And if we reduce that change of x, then the length of that segment gets smaller and smaller. So kind of in theory, the same thing as when we're doing Riemann sums and area, and we reduce the change of x or the width of the rectangle, so it gets smaller and smaller. So let's go ahead and start with what we're familiar with, what we know. Okay, so according to this, we would say that the length of that segment is equal to Pythagorean theorem. If my A was change of x, I would say the change of x squared plus the change in y squared. And then it's L squared, which is the hypotenuse, equals that. So to isolate L, we would take the square root. So that's what we're used to in terms of both Pythagorean theorem and the distance formula. And so from here, what we're going to do is take this, and again, we're visualizing that this length that we see over here on the left is really the length of one of these segments. And so to make a few adjustments here, what I'm going to do is, can you guys type into the chat yes or no for this question? Okay, so in theory, if I multiply by change of x over change of x, does that change the formula in any way? If I multiply by change of x over change of x. Okay, in theory, your overall equation is still an equation because change of x over change of x is still 1, right? So you're just multiplying by 1. So what we're going to do now is use those two expressions and move this change of x so that it's inside my square root. Okay, so when I do that, I end up with the square root of, let's say the top is change of x squared plus change of y squared. And when I move that change of x inside, for it to be equivalent to just change of x outside of the square root, what I would have to do is square it. Okay, so think of it if I were to ask you guys to simplify it, right? The square root of change of x squared is change of x. Does that make sense to you guys, what I did there, why I squared it? And if no, can you guys let me know too? Does that make sense to you guys? Why I had to square that change of x? Okay, because in theory, the change of x squared, the square root of that is just the regular change of x. Okay, so still we have the top change of x on the outside, so I'll keep that on the outside. And I'm seeing that it makes sense so far, so that change of x stays the same. Okay, so now what I'm going to do is, because we have a fraction with the monomial at the bottom, we can split this. So change of x squared over change of x squared is 1. Change of y squared over change of x squared is going to be, and I'm going to change the notation here, is going to be square root of 1. Sorry, I'm still getting used to my colors, so I didn't intend to change these colors the way they are. So 1 plus, and then instead of change in y and change of x, we're going to switch it over to another notation for differentials, which is dy. So change of y is the same thing as dy. Change of x is the same thing as dx, quantity squared. And then on the outside, we'd have times dx. Okay, so that formula now, we have dy dx. What does dy dx represent? What's dy dx represent? Slope, derivative, very good. So to find the length of something, we would say take the square root of 1 plus the derivative squared. And then in theory, because this is just one little segment, and we want to sum up a bunch of segments here, sum is integral. So we're going to replace the sum with an integral, and we get the integral of square root of 1 plus dy dx squared times dx out here. Again, just it went within the integral, that just represents with respect to x. And then because this is with respect to x, my limits of integration would be x equals a, x equals b. The a and b in this case would represent, just like when we're doing area and volume, the beginning of your interval to the end of your interval. So in this case, whatever the x value is for p sub 0 and p sub n in that case. Okay, so I want you guys to pay attention to this aspect, this step right here that I did. Okay, so, or actually back to this step. So if I had done the whole thing again, but instead of change of x times change of x, I did change of y times change of y, then I can technically do the entire thing again and still end up with a equivalent formula, but this time all with respect to y. So similar to area when it's with respect to x and with respect to y, we're going to have two formulas for arc length, one with respect to x and one with respect to y. So the one with respect to y, if I had done all the steps the same, let's say you get up to this part and you guys had divided by dy instead, you would have 1 plus change of y over change of x. Or sorry, reverse that. That's what we did earlier. So change of x over change of y, quantity squared, and then change of y on the outside. So this is the equivalent equation if we had divided everything by change of y. And so the integral part, so I'm just going to put an or here, is if I were to sum up all the lengths, it would be from y equals a. So lower value is the lower y value is going to be a, and upper y value is going to be b, similar to area and volume. And then 1 plus, in this case, dx dy. So this is all in terms of y, times dy. So pretty easy to remember this formula. I think if you guys have to, you could derive it again, but you will have to know these two formulas for your test next week. So go ahead and box those two formulas. Okay, and if you guys can, go ahead and transfer those formulas down here. There's boxes for it. If you guys want to transfer it, you can. If you don't, you guys are good. It's up there as well. But you have one with respect to x. It just kind of summarizes what you're doing here. And it does mention that it has to be a smooth curve as you're doing these problems, that it's a polynomial type curve, or sine, cosine are fine as well. So length here, y equals a, y equals b. Actually, in fact, this one switches it to c and d as the variables, so I'll do the same here. So y equals c and y equals d is your upper and lower limit of integration. And then this one would be dx dy squared. And just as you guys are doing this, notice, maybe highlight the fact that within the sentence above those boxes, it mentions that y is in terms of x on the top equation, and then that x is in terms of y on the bottom equation. And you're not forced to, I guess you're forced to use the easier one, whatever is easier in the context of the problem. So if everything is given to you guys in terms of x, you're going to want to use the top equation. And if everything's given to you guys in terms of y, you're going to want to use this equation. You don't want to convert or rewrite the original equation in terms of a different one. If you're given it already in terms of y, you're going to go ahead and use the bottom equation. Now, we'll quickly see that there's only a few problems that you guys can actually do here without a calculator. If you think about taking a derivative, squaring it, then adding a 1 and then taking a square root of that, it's not going to result in something that is very simple to solve. So what's going to happen is a lot of the problems are going to end up being ones in which we have to use a calculator for. There's a few, like on your homework assignment and like example 1, where we will be able to do it by hand. But again, most cases, they're either going to give you guys this AP problem that I'm going to show you guys down below, or it's going to look a lot like example 2, where it's just calculator. Okay, so in this example that you guys have here, it says find the arc length of y, everything's with respect to x. And then so you guys can make the assumption that if this is it with respect to x, that these are going to be x values right here. So this is x equals, and I can say a to b. This is your interval. Okay, so we know that we need the derivative. So what I'm going to do on the side is kind of like the way I do big R, little r, is find those things as steps along the way. So if I take the derivative of that, I get 1, 2/3 times 3/2 is 1, x to the 1/2, and then the derivative of 1 is just 0. So from there, you guys are going to recognize that you do have to square as well in the formula. So if you do that as a step here, and you square the above, you guys get square root of x squared is just x. So let's go ahead and plug that into our formula. So the arc length from A to B would be 0 to 1 of the square root of 1 plus, so the formula is 1 plus the derivative squared. So in this case, 1 plus x, and then with respect to x. Now I can see here that I can either do u substitution in my head, because this is linear inside here, or if I want, I can just do u substitution quickly enough with this problem. So u equals 1 plus x. When I take its derivative, I get du equals dx. And so let's sub everything in. So if this is, and I'll practice doing it this way with you guys. If this is u equals 1 plus x, and I plug 0 in, because these are my limits of integration are currently in terms of x, then I get u equals 1 at the bottom. And then I get u equals 2 at the top. And so that is changing it so that, yes, the derivative squared is not the same thing as the second derivative. That was a question that someone asked. It's just squaring the expression that you had for the first derivative, as opposed to actually taking the derivative of a derivative. Okay, so then from there, you guys have square root of u. And then if we replace dx with du, this is the expression that you guys have for finding the antiderivative. So here we have u to the 1/2. So if I add 1 to that, I get u to the 3/2 times it by the reciprocal. Then I can plug my 1 and my 2 in. Okay, and so at this point, remember when you guys are doing u substitution, if this is u, these limits of integration have to be u as well, which I had changed. So if I plug the 2 in, let's just come up with the expression for this, because otherwise it's not really a nice number that I get, but I get 2 to the 3/2 minus 2/3, 2 to the 3/2, or sorry, 1 to the 3/2. Which if you guys simplify further, is just minus 2/3. So we're going to leave our answer like this and then move on. Does anyone have any questions about that? I think it's a pretty straightforward example in terms of it. So just remember the derivative, then square the derivative, plug it into the formula, which has the square root and 1 plus that derivative squared. Okay, so we can see that by kind of think of this problem like when I took the derivative, it ended up making it really simple. And then when I squared it, it simplified it even further so that my expression within the integral, the integrand itself, is really simple to find the antiderivative of. In most cases, that doesn't happen. So even within a problem like this, we're going to have to use the calculator. So in parentheses up here, you guys can put calculator. This is a calc problem. Okay, so go ahead and find dy dx for me. Actually, why don't you guys attempt the problem? It's a calculator problem. So I would do the derivative by hand and then square it and plug it into the integral and then do the integral by hand. And you guys can look up if you're like kind of rusty here and you're not really sure. You guys can always take a glance up, but go ahead and find the derivative, square the derivative. As you guys are doing this problem, make sure you guys practice doing the integral on the calculator. This is pretty simple in terms of you don't have to store anything. I would go ahead and just enter the whole full integral that you see right there into your calculator and see if you guys get the same answer. And then go ahead and type your answer in once you guys think you have the answer for that. Okay, good. Most of you guys typing it in, I see is the correct answer. I would make sure if you guys are typing it in, good, make sure the 1 plus x and negative 2/3 is inside the parentheses. I have a few people coming in with 10, like an exact 10 as an answer, and that wasn't correct. If you guys can try to type the entire integral inside, I'm not sure if you guys are trying to do it by hand at all, but it should be the integral and then make sure you have 1 and 8 square root and then double check. Okay, I see some people correcting their answers. And if you guys could, if whenever you guys are typing it in twice and it's a corrected answer, just go ahead and put an asterisk by that so I know it was corrected and you guys have the right answer at this point. Okay, good. So if you didn't get that, again, I want to remind you guys of the option to, especially with calculator, screenshot what you guys have right now, and then send the picture or the image to me on Remind, and I can just do a quick check of your calculation. That works as well as me walking up to you guys and looking at your screen. So sometimes it's a matter of just like a typo on the parentheses. Okay, good. All right, you guys. So in the next example, we have just a few minutes left. So in the next example, you guys have find the arc length of, and that says x equals e to the negative y. So we see here that we have things with respect to y. So we can make the assumption here, unless it tells us otherwise, that this is going to be y equals 0 to 2, that those are going to be y values. And if it does say that it's x values, you would then have to make the substitution back. I haven't really seen people or the AP tests do that, but that's just something to keep in mind. In most cases, they give you the interval with respect to the same variable that the equation is written in. So in this case, instead of writing dy dx, we would write dx dy. And that's just to say, I'm going to take the derivative of x with respect to y. So there is no implicit here because what we're taking it with respect to is y here. So it's just a regular derivative. So the regular derivative is e to the negative y is itself times chain rule. The derivative of negative y is -1. And again, we wouldn't do implicit because we're not taking it with respect to x, we're taking it with respect to y, and this is in terms of y. So if I square that expression, I'm going to get e to the negative 2y. And so my arc length formula, we're going to assume that's 0 to 2. And what I'm going to have us do, again, remember your formula is the square root and 1. I would say that one of the common mistakes I see is forgetting either to square it. That's why I kind of do this two-step process on the outside, or forgetting the 1 plus. And what I'm going to do is have us come back to this calculator question. I do want to get to that last question. So that's a matter of just entering it in. So if I can have you guys look at example 4 with the time that we have left. Can you guys put a star here? This is a common way that the AP readers have addressed the fact that when you do the process of taking a derivative, squaring it, that the result is something that is not easy to integrate without a calculator. So then they changed the formatting of the problem. And I apologize, I just noticed that I put squared on here, which I didn't mean to do. So this one is just the derivative right there. And the correction was made right here. Okay, so here, instead of giving you guys the original formula, they're giving you an expression for the length. So the length of a curve from x equals 1 to x equals 4 is given by this expression. If the curve contains the point 1,6, what is the equation of the curve? So if you guys can highlight this, this portion right here, some people will come back and ask me, what is that asking for? That is asking for the original equation. Okay, what's the original function? What is f of x or f of y in some cases? So in this case, we see that it's going from 1 to 4. I want you guys to go ahead and circle 9x to the 4th. And in the chat, can you guys tell me, what does 9x to the 4th represent? What should I say 9x to the 4th represents? Okay, good. What I see coming through is most of you guys have dy dx, it's dy dx squared. Okay, so don't forget that it's squared in the formula. So we want to recognize that it's dy dx squared. Okay, so to undo the square part, to just get the derivative of the function, we would say dy dx is equal to the square root of, I'll just put the square root here. If you guys take the square root of both sides, you end up with 3x squared. Okay, so now if we think about the problem, now we have the derivative and they want the original equation or the original function. And then there's this value here. What would you guys say 1,6 is? What's that considered? Why did they give me that value right there? The curve goes through the point 1,6. Okay, excellent. I see a few people, good, saying it's the initial condition. It's enough to solve for my plus c. Very good. So if I have dy dx is equal to 3x squared and I want the original function, that means I do have to integrate. And when I integrate, I get the general antiderivative is x cubed plus that c. So if I want the equation of the original curve, I'm going to need to know what that plus c is. So that's going to be the initial condition that you're going to use to solve for what c is. So if I plug everything in, I get y is 6, x is 1, c is therefore 5. So the answer to this is, I'm going to write it on the left, y equals x cubed plus 5 is the original curve. Does that make sense to you guys, the process in which we solved for that? And that takes care of you guys recognizing what the formula is, that you understand that that's the second derivative squared, to remember to take the square root of it, and then, and this is a really common problem on the AP test as a multiple choice question. And you guys can see that's a clever way of asking you guys without having to do the whole calculator and worrying about the calculator. So I'm going to go back to example 3. We're going to wrap up with that. We actually did have time for it. Can I have you guys do, especially if you guys made that mistake earlier, can you type that into the calculator? Just keep in mind when we're in terms of y, it doesn't matter. On your calculator, you guys can use the x variable and then type in your answer. Let me know what you guys get for this one, for example 3. Good, the ones coming through are correct. All right, you guys, I see 2.221 consistently, 221. Round to 3 decimal places is what we normally want.